All right, we left off at drawing an ammeter. So an ammeter is used to measure amps, and amps is the unit of measurement for current. Current is the flow of electrons. So if you think of current like the current in a river, the flow in a river, it's the same thing for a circuit. The electrons flowing through the circuit is the current of the circuit. Okay, so this ammeter would pick up all these electrons flying by it and it would measure them. Okay, the next one on here is a voltmeter. So when you did your definitions yesterday, you found out that volts are the measurement, voltage is the measurement of potential difference. The difference between before a resistor and after a resistor, or before a load, they're called, and after a load. So if I wanted to draw a voltmeter, I'd take my pen. I have to show the difference between before the bulb and the difference after the bulb. So a voltmeter actually has two measurements. That's how you would hook up a voltmeter if we were actually hooking it up. And when you do that in your simulation, you actually do have to have two little prongs that show you before and after the load. So right now we are measuring the voltage across this light bulb. We're measuring the difference between the voltage here versus here, before and after that energy goes through that light bulb. Okay, so that would be a voltmeter at the bulb or at the load. If you were drawing a voltmeter at the battery or at the source, sometimes they call it the source, then you would piggyback, we call it piggybacking. You'd piggyback your wires before and after the battery. For this, I would then erase right here, and I would put my little voltmeter sign. We are measuring volts. Now, if you take a look, there's a little, I know this is getting picky, but there's a little space in my wire right there. That would be a broken circuit. We want to make sure that all of our lines are absolutely connected so that it doesn't represent sort of a broken circuit, and actually the whole light bulb would go out. The whole circuit would be broken. All right, and then bulbs in series. Okay, if bulbs are in series, they're going to be one after the other after the other. When you think of a series in novels, for example, you have an entire series is one novel after another book, after another book, after another book. That's what's happening in a series circuit. So if I were to draw two bulbs in series, I would just put a second bulb on the same wire. They're sharing the same electrons. So I would do, oh, that's a pretty sad light bulb, but that works. Okay, so all the electrons would be going through this bulb, and then they would be going through this bulb in series. So they share the same wire. That's how you do a series circuit. A little side note, if, let's say, a filament in the light bulb burns out, so in other words, this little guy right here burns out, you just broke your circuit. If you broke your circuit, that means the electrons are not, it's kind of like an open switch there. The electrons are not going to be able to fly around. And that means that the circuit's broken here, which means this light bulb will go out as well in a series circuit. They're all on one wire. If the wire is broken at any point, even if it is in the light bulb, both bulbs will go out. Okay, so that is a series circuit. If we go to this one, it wants you to practice drawing. So it wants you to practice a battery. I'm going to try to do this quick so that we can do it all in one video. There's your battery, minus terminal, negative terminal, and positive terminal listed. 4 bulbs in series. We have to show on this one wire. So I'm going to draw my whole circuit first because it's easy to erase with this thing. And then I'm going to put one bulb here. I'm going to put maybe one bulb here, one bulb here, and maybe one bulb here. So go back and get my pen. Make a nice little light bulb. Meow. Okay. Nice little light bulb. Try to make it really joined so there's no breaks in my wire. You guys likely will make these a lot prettier than mine are. 3 light bulbs in series and 4 light bulbs in series going off the side of the page. Open switch. Okay, so we need a switch. It says an open switch. And actually, that's wrong on the diagram. If the switch is open, it's actually off. But if it wants an open switch, we'll give it an open switch, but the circuit would actually not be, the lights would not be on right now. So that was a mistake on here. I'll fix it on yours. Flow of electron arrow. So we need electrons coming out of the negative terminal. There it is with a little E. And then we need an amp